Now, welcome once again. Now, discussing modules, all the modules in your car. Now, this discussion is going to be related to how do they communicate to each other. Now, you can have many modules for the air conditioner, powertrain control modules is the PCM, one for ABS, one for the braking system, one for the radio, one for the lighting control module. Obviously, you can have many. The problem is we want to try to get as many talking to each other, communicating to each other as we can. This is a body control module, vehicle control module, body control module again. Therefore, they have to be able to talk to each other. In order to understand the concept, we have to try to simplify, because I know there's beginners watching the channel. So let's try to simplify it as much as we can. Okay? Let's say these are the modules that I always use. This one we're going to put aside. Let's say these are the modules. Okay? Body, PCM, body control module. This could be the lighting control module. There has to be a way that these communicate to each other. What do I mean by that? That means he can talk to him, and he can talk to him, and he can talk to him and him whenever they want. So in other words, they all have to communicate to each other, and they always have that opportunity to do that. How do you do that? We have something called a common bus line. If you go back to the schematic, and I didn't want to refer to it too much because it's a little complicated and confusing. This is a common bus line. You see, all these modules are connected to a common bus line. See how many modules? They all come to this common point. Why do we do that? Let's understand what's going on first. Now, we said we have a power control module. We have a body control module. We have a lighting control module. However you want to signify each one, doesn't matter. They want to talk to each other. They have to speak the same language. In other words, if he speaks English, he has to speak English, and he has to speak English. So let's simplify it as best as we can for beginners. They all have to have the same language. If he speaks English, and he speaks French, and he speaks Portuguese or whatever, no communication will be among them. That's problems. In the world, in the industry of digital electronics and also automotive electronics, they communicate to each other not by the old-fashioned way of analog. And analog meaning a sine wave, let's say 1 volt, 2 volt, 3 volts, 4 volts, 5 volts. They don't communicate like that. Instead, the digital, where you have this is the zero line. You have 5 volts as a high or 0 volts as a low. Now, sometimes being technical, sometimes you have 2 volts. It depends what the processor sees. You might see it as a high or a low. We're not going to get too involved with that right now. Basically, he sees something on or off, high or low. That's the only thing the processors, by the processor I mean these ICs. These ICs only understand the digital language of high and low, 5 volts or 0 volts. 5 volts, you cannot have analog. So therefore, he understands digital, he understands digital. Now we have everybody talking or speaking the same language. Fine. He wants to speak to him, right? You want to make everybody universal, that they can be able to talk to each other. How do we do that? Okay, try to do this with one hand. The easy way. This is one over here. Let's see if I can get it. Hold on. Okay, if you're confused what you're looking at, let's try to unconfuse you. One module is connected to, let's say by the green one. This is a data bus line. Bus line means a common bus line to everybody. How does it work? We all said they are digital information going out. Highs and lows. This one PCM is wired to or connected to the body control module through this green one, as you can see. Fine. What about the lighting control module? Lighting control module he wants to be connected to him and him. So what do? You take a wire and connect it to this wire, either here or here. It doesn't matter where. But as soon as you connect this to this one, you're connecting all three of them together to a common bus line. Let's see how it works. He wants to speak to him. Okay? He'll send out a signal to him. Okay? He will send a signal back to him. Let's say he wants to speak to him through the red wire like this. Okay? Let's say this guy wants to speak to this guy, right? Through the red and to the green. Any way you look at it, there is a path for each one of these to speak to each other. Now, the wrong way, or the older way, was you take this one to this one, then take this one, then take another wire from here to here, like we done over here. This allows us to have a common bus line. The older it was to put everything in series, which was a waste of wiring. This is the method that's used today. Data bus lines. Everything has a common port, a common connection. So he can speak to him and he can speak to him. He can speak to him, he can speak to him. So now we resolve the problem. Okay? Now we understand something, hopefully. Let's go to something a little more complicated. Let's say he wants to speak to him. Well, like we said, in the world of digital, you have CAN bus lines and all kinds of serial data. Wherever you have serial data lines, that means somewhere this one is communicating to this one, and this was communicating to this one. Wherever you see data lines. Let's say you ever have, if your router or your cable company, they want to see if something works. How would he communicate to him? Well, let's say upon startup of your car, and this is why I'm getting into it. There's like a boot up. He has to make sure he can communicate. If there's 20 modules, he has to make sure that he can communicate to all the modules, the PCM, the BCM. Everybody can speak to each other. You're going to send the code. Let's say you're going to send 101101. He's going to send him that code to wake him up, to make sure he's communicating to him. He's going to go back and send him the same code. That way they know they're on the same line, that they are speaking to each other. He's going to send this code. He's going to receive an email with this code. Let's make it simpler. When he gets that code, he's going to send an email back to him with the same code saying, I read what you wrote to me and I'm writing back the same information. This is how everything works. That's how he says, you know what? Now I know that module is alive. Okay? So now we understand, hopefully, the basic concepts of the modules. Like I said, it varies among makes and models of cars. I don't want to get too involved with, like I said, CAN bus line, things like that. It'll be later on. But just to make it so simple for the people, the beginners, you have to have a communications line that everybody can speak. And sometimes one module will have priority over another one. Let's say the body control module has priority over the radio module or the lighting control module. You cannot afford to lose a body control module. So if something happens and the line is busy, as we say, the line will stop. He will communicate to him and say, I have a problem with this module. It depends on the priority. Let's say, like we said, the radio module, the lighting control module does not have that much priority compared to the other ones. Therefore, data is sent. It's called data. Data is sent on the line, 10s. As soon as something comes up, he's sending data, but he doesn't hear from someone. It's like an interrupt will happen, and then he'll put up a code or whatever. No communications to whatever, a body control module, or body control module has no communication to PCM, or lighting control module. Again, it depends on the priority of the module. Which one is more important than the other one? Obviously, a radio module is not that important. Or air conditioning module. It depends. Okay, now, hopefully you understood that. Okay? Here comes the problem. You turn on the car in the morning. Turn on the car in the morning, doesn't start. You get a message on the dashboard, on the instrument cluster, that tells you anti-theft deterrent module. Now, that's a problem. You can't start your car. Anti-theft deterrent module. This will represent that module. Right? This is, your alarm went on, and all that. You didn't pay attention to it. You come in the morning, and guess what? Now you see I can't start my car. The processor, or the module detected there was a problem with this module. Or it told it, you know what? I was activated overnight. Why? Anti-theft deterrent system. Let's say somebody tried to open the door. Obviously, he wanted to break into the car. That's what our anti-theft deterrent system is, for the alarm to go off and the horns to go off. Let's say somebody wanted to go into, he opened the doors. Therefore, the module, speaking to this one, will say, we're not going to let the car start. We don't know if it's the driver. We don't know if somebody else, a stranger, or a criminal trying to break in. Of course, nowadays, you have all these fingerprints. We're not talking about that, but we're just talking about the simple situation. Okay? Now, let's say, we just said before, he broke into the car with the door. Let's say he didn't break into the car using the door, because that activates a switch, the door switch, which triggered the module. Now, instead of that, the glass was shattered. Wanted to break in by shattering the glass. What do you think is going to happen with the module? Is the module going to activate an alarm? It depends on the make and the model. Everything is different. So the make and the model, let's say, when someone breaks the glass, let's say he breaks the cargo glass in the back, or the trunk glass, right? It creates a sound. The module on some vehicles have a microphone. The shattering of glass produces a sound, a pitch, a frequency, an audible frequency. That frequency is detected by the microphone on that module. Even though he didn't open the door, he didn't trigger any switch, the sound itself of shattering glass, and you cannot miss it, produces a sound, and a loud sound. Therefore, it takes that sound, amplifies it after it went through the microphone, tells the module, you know what, somebody is vandalizing the car or trying to get into the car. Pay attention to the driver. Now, either going to have that something, you have a security, it blinks, whatever. Whenever something blinks, it's trying to get your attention. It's trying either a check engine light or security. It's trying to get your attention to do something. So, in that instance, you have to be aware of the anti-theft deterrent system to disarm the alarm system. But let's say, for instance, because the PCM needs a signal from anti-theft system that everything is good. If he doesn't get a signal or a voltage from him, PCM will say something is wrong. I cannot let the relay of the starter motor relay be activated. He gives a ground. We just spoke about grounds from the textbook in the previous video. His responsibility is to give a ground to the relay to activate the starter motor. He will not give a ground if he has sees a problem with the anti-theft deterrent module. Let's say you get the warning on your dashboard, anti-theft deterrent system disabled. What does that mean? That means you cannot start your car. That means that there's a problem with that module, and the computer disregarded it. In other words, it's telling the computer how smart they are. It's telling you there's a problem with the anti-theft deterrent system. I am warning you right now to the driver, you might be in danger that somebody might be breaking into your car. Why? because there's a problem with that module. How does he know? He either get the signal or he sent the signal, an email to him, he did not respond. Either way, he knows the PCM is smart, or the VCM or the ECU. They're smart. They know. How do they know? The programmers. The program put the instructions in the microprocessors for every possible situation, what his action should be. We just said an action gives off a reaction. Okay? The action was this was disabled or it was defective. That reaction by this one is, let me shut off the car. Until you take care, or let me not let the car start, because you have a module, anti-theft deterrence module, where someone can break into the car. Pay attention to that. Take it to whatever you have to do to get it fixed, because you cannot afford to have your car without an alarm system. So how, like I said, programmers write instructions into millions of instructions in a second in a microprocessor. Therefore, when we talk about communication, a data line, that's what we're talking about. But let's take it a step further. We just spoke about this module is speaking to another module. Okay? PCM module. My writing is not that great, but talking to a BCM module, body control module. They have to speak to each other. He sends him, we just said he sends him a code. Okay, going this way. The arrows means it's going this way to him. He's waiting for him to respond. He doesn't get anything. When he responds, the data flow is this way. He's sending him an email saying, I'm sending you a code. Let's say this is the code, whatever. He's still waiting and waiting and waiting. Come on, BCM module. Come on, answer me. I just sent you an email. Right? No response. Absolutely no response. Question mark. Why? Now a question mark to him. Why? What's going on? We have to evaluate. We have to diagnose the problem. This is a transmission line. Transmission. This is a receiving line. With regard to who? This is the difficult part that people have difficulty with. With relation to him or regard to him, he's transmitting to this module. With relation to him, he's transmitting to him, but he is receiving from him. So it depends who you're looking at. Again, in order to troubleshoot effectively and diagnose correctly, who are we dealing with relation to who? This one is transmitting data to him. Who's the receiver in that case? The BCM is the receiver. Who's the transmitter? The PCM is the transmitter. Now he gets the email, the code. He sends back a code. Who's the transmitter in this case? He's the transmitter. Who's the receiver? He's the receiver. Depends who you're looking at. Okay? Now, he did not answer. We just said you sent him an email. He never responded. This is the tough part. Did he not respond because of one of two possible variables? Either he heard it, he heard this code, the email, he received it, but he had a defective problem in his module and he cannot send back data to him. That's case number one. Case number two is he never received the email. He says, I'm sending you an email, right? A boot up we're doing, right? Checking all the modules when you start up that car. He says, you know what? You're waiting for my email. I never received an email from you. How can I send you back an email? So in other words, this has nothing to do with this line. It has something to do with this line. So if he never received it, he cannot transmit data. This is the most important part when you diagnose in some makes and models of cars communication lines. Again, one more time. He never received this. Never received it. If the BCM did not receive the email, which line are we dealing with? This one. This is the problem line. But let's say he did receive it. I got the email. I sent you an email, but guess what? It never came to you. Then which line is the problem? The receiving line. This is the problem. This is The foundation. How do I know this? From the textbook. The textbook, Automotive Technology, a Systems Approach. And therefore, this is how I learned automotive electronics. The best guide was my textbook until today, as you can see. So therefore, I hope you understand the concept of this, trying to simplify it as possible as I can. I know I'll show you the schematic, and it'll be like, you'll be confused. But please, if you like this channel, if it was informative, please subscribe or give a like or comment. Joe, Electronic Schematics for Auto. Hope to see you in the next one.